The next type of the differential equation that we're gonna study is called Bernoulli equation. The Bernoulli equation look like linear equation. However, if you see that the pattern or the form of the Bernoulli equation, you have y to the n after qx, or you have y to the n multiplied to qx. If you have this term disappear, it's gonna turn out to be just the linear equation that we have seen before. So for the Bernoulli equation, you're gonna just first identify Px and Qx, okay? And we're gonna use the substitution, and we're gonna be able to convert from the Bernoulli equation to the linear equation, and we're gonna use the way that we solve linear equation to solve the Bernoulli equation, okay? So the way to do the substitution will be we're gonna multiply both sides in order to get rid of y to the n. So you see this guy is extra term and you have y to the n. So we're gonna get rid of y to the n by we're gonna just multiply by y to the minus n. Okay, so you're gonna multiply y to the minus n, and you also multiply with 1 minus n. Okay, so it's going to be 1 minus n, y to the negative n, dy dx, and everything turn out to have this term. And you see that, okay, and you see that if you use the substitution, so if you let z equal to y to the minus n, sorry, if you let z equal to y to the 1 minus n, so if you let that equal to y to the 1 minus n, let me enlarge this one to see this guy clearer. You're gonna be able to have sad here, okay? So this guy is gonna turn out to be sad, okay? So this guy turned out to be sad. And you see this term is gonna be u d dx of y to the 1 minus n. When you d dx of y to the 1 minus n, 1 minus n will come down, and you have y to the 1 minus n minus 1, and they will give you just y to the minus n, and by using the chain rule you have dy dx. So this one and this one turn out to be identical. Okay, so this one and this one turn out to be identical, and they just have the dx of y to the 1 minus n, okay? And you're gonna have, this one is gonna be the dx of y to the 1 minus n, and let me circle this term. So I will just circle this one for you. So this term and this term turn out to be identical, okay? And you have 1 minus n qx. So we will let that to be y to the 1 minus n, okay? So you will let that to be y to the 1 minus n, and this guy turned out to be in terms of linear equation. Okay, so this guy turned out to be a linear equation that you're gonna be able to solve this one by just using the formula for mu and the formula for z. Okay, so that is gonna be the way that to solve this Bernoulli equation. So let me conclude first that the way to solve Bernoulli equation will be you gonna identify n, okay, identify n, and you're gonna let z equal to y to the 1 minus n, and you're gonna convert from this equation to this equation, and this guy turned out to be a linear equation. Okay, so we're gonna have like a two-step in order to solve the Bernoulli equation, convert, and so by using the linear equation. Okay, so for this one, let me identify px and qx for you. So you're gonna have dy dx plus negative 1 over xy equal to e to the x squared times y squared. So you see that if you compare with the pattern for the Bernoulli equation, this guy will be your px. Okay, so let me just have this term. Okay, so this one is going to be your px, and this term will be your qx. Okay, so this term will be your qx, and here you have n equal to 2. Okay, so we identify px, qx have n equal to 2. So the thing that we gonna do is gonna be we gonna let z, okay, equal to, okay, y to the 1 minus n. Okay, so you let z equal to y to the 1 minus n, and you gonna have dy dx. Okay, so you have dy dx we gonna convert. Let me just have this one is y to the 1 minus 2 equal to y to the minus 1. Okay, so you let z equal to y to the 1 minus 1. Okay, sorry, y to the minus 1. Okay, you let z equal to y to the minus 1, and you convert this guy to linear equation. Okay, convert to dz dx plus 1 minus n px z equal to 1 minus n qx. Okay, so you convert to the linear equation in this form, and you're gonna put everything. So you have dz dx plus 1 minus n is going to be 1 minus 2. Px is going to be negative 1 over x. Okay, and it's going to be z equal to 1 minus 2, and qx is e to the x squared. And you get the z dx plus, okay, and you have 1 minus 2 times 1 minus x, so it's going to be 1 over x z equal to negative e to the x square. Okay, so it's going to be negative e to the x square, and this guy is linear. And after you know that this guy is linear, you're gonna identify new px and qx. Before I have px and qx up there, okay, so it's gonna be new px and qx that I'm gonna use the the angle px, and I'm gonna have qx. Okay, so it's gonna be different from the above. So it's going to be new px and qx for linear equation. And here you're going to have mu equal to e to the integrate new px dx. So it's going to be e to the integrate. Okay, so it's going to be e to the integrate of 1 over x dx. So it's going to be e to the log x. So it's going to be just x. Okay, so you have mu equal to e to the x, and you're gonna have z, not y. Okay, so we are solving for z. Okay, so we are solving for this z because the variable here are z. Okay, so you have z equal to what is going to be 1 over mu integrate mu qx is going to be q that have angle, or q square like this. Okay, so it's going to be 1 over x. Okay, and you integrate x negative e to the x square dx. Okay, so it's going to be this one. And this one you're gonna have 1 over x, and you gonna integrate e to the negative x times e to the x square. So this one you're gonna just use the substitution. Okay, let me just have integral. Okay, so this one is gonna be the integral that we used to have like in terms of parentheses. Okay, so the x like this one, and this guy will be the substitution. So this one is going to be u equal to x squared du equal to 2x dx. So you get negative 1/2 du equal to x dx. Okay, so it's going to be 1/2 du, not negative. So it's going to be 1/2 du equal to x dx. So for this one, it's going to be integral of e to the u negative and 1/2 du. Okay, so this one will be just this term and this term. Okay, and you integrate this one, so you get 1 over x. Okay, so you get negative e to the u over 2 plus c. Okay, so you would have 1 over x, and it's going to be negative e to the x squared over 2 plus c. Okay, so this one will be your final answer. And by the way, you're gonna have to change everything into y. Okay, so we have let z equal to y to the negative 1 up here. Okay, so you have z equal to y to the negative 1. So for the final answer, you're gonna have y to the negative 1. Okay, so this guy, you have to change into y to have the corresponding variable that you are looking for. So you have y to the negative 1 equal to this one, and this will give you the general solution that you are looking for. Okay, so this one is going to be the thing that called Bernoulli equation. Okay, for Bernoulli equation, you first identify px, qx, and n, and you're gonna use this formula to convert into the linear equation in terms of new variable z. Okay, it looks like doing substitution. Okay, it looks like doing substitution, and you're gonna solve for z by the formula for mu and for z, and you're gonna be able to obtain everything. And at the end, you're gonna change z to y, and you're gonna get the final answer. Okay, I will do number 2 a little bit for you, but I'm gonna let you continue doing this one. So you see that you have x dy dx plus 6y minus 3x squared y to the 4/3. So here, in order to put into Bernoulli equation, you would get dy dx plus 6 over x times y minus negative 3x y to the 4/3. So you see that you divide by x and you get rid of x and square here. That's why you have 3x, okay? And this will allow you to identify px. Okay, so this one will be your px, and this one will be your qx. Okay, so you have px and qx. Okay, you have px and qx, and you're gonna convert this one. Okay, this one is binary. Don't forget that it's gonna be, you need to identify n, and n in this case is equal to 4/3. Okay, so you have n equal to 4/3. You have 1 minus n equal to 1 minus 4/3 equal to negative 1/3. And you're gonna convert this thing into linear equation. Okay, so please do this one. I will do another one. Okay, So for the next one, you have kind of not nice equation. Is kind of like a group together into something that like complicated. Okay, this one is not uh, non-exact equation. However, you can put in terms of non-exact equation, you're gonna see that it's kind of complicated for dm, dy, dn, dx is gonna be very messy. So for this one, we're gonna try to write in terms of y prime something, okay? So we're gonna just multiply everything. So you have y to the fourth x y prime plus y to the fifth equal to x over square root 1 plus x to the sixth. Okay, so this one will be just, you can just multiply this guy to this term and this guy to this term. So you would get y to the fourth x y prime plus y to the fifth, and this x you group with on the other side. And at the next step, you're gonna get rid of everything in front of y prime. So for this one, you're gonna get y, okay, so it's gonna be plus 1 over x y equal to, and this one, you're gonna have x over square root 1 plus x to the 6, and you're gonna multiply with y to the fourth x on the bottom, and you see that x and x will cancel each other. So this guy will turn out to be 1 over square root 1 plus x to the 6 times y to the negative 4. Okay, so this guy is Bernoulli equation with, you have px, okay, so this one will be my px and this one will be my qx, okay, and I have n equal to negative 4, okay, so I have n equal to negative 4. So I have n equal to negative 4, so 1 minus n will be 1 plus 4 equal to 5. Okay, so this is going to be the thing that we shall use next. So I would let z equal to y to the 1 minus n. So it's going to be y to the fifth. Okay, so that will be my z. And we convert to, okay, so we will convert to dz dx plus 1 minus n px z equal to 1 minus n qx. Don't forget 1 minus n. 1 minus n will be important. Okay, it's not just constant multiple. Okay, it's going to be important in order to find mu. And if you forget 1 minus n, the integrating factor turn out to be changing, and you're not going to be able to solve for that. Okay, so that's important. So for this one, you have dz dx plus phi, px is 1 over x, okay, and you have z equal to, okay, and the next one will be phi qx, so it's going to be 1 over square root 1 plus x to the 6, and that's it. Okay, so this one is going to be linear. And you're gonna have mu, okay, equal to, okay, so we're gonna identify new px. So the px turn out to be just 5 over x, and you have qx, okay, so qx turn out to be this guy. Okay, so you have qx to be this guy, and you have mu. Okay, so you have mu equal to e to the integrate px dx. So for this one, it's going to be e to the integrate phi over x dx. So it's going to be e to the phi log x. So this one will be e to the log x to the fifth. Okay, and you have phi come up here. Okay, you have 5 come up here. So for this one, they will cancel each other. So you would get x to the fifth for mu. Okay, so you have mu equal to x to the fifth. So this one will be your integrating factor. Okay, and you're gonna have that. Okay, so you're gonna have that equal to 1 over mu integrate mu qx dx. Don't forget to use the qx that you have down here, not up there. Okay, so it's going to be the square qx here. So you get 1 over x to the fifth integrate. Okay, so you have x to the fifth and you have 5 over square root 1 over x to the sixth dx. And you're gonna have 1 over x to the fifth, and you're gonna integrate this guy by using u equal to 1 plus x to the sixth, and you have du equal to 6x to the fifth dx. Okay, so you would get what is called du over 6 equal to x to the fifth dx. Okay, and you're gonna have what is gonna be? It's gonna be integral of 5. Okay, and you have du over square root u and du over 6. Okay, so for this one, okay, so this one will be the integral du, and you're gonna change this guy to 5, 6, and integrate root u is 2 root u plus c. So this one will be the parentheses for the integral that I told you before. And for the final answer, you're gonna have 1 over x to the fifth, and you have 5 over 3 square root 1 plus x to the sixth plus c. Okay, so this one will be just this guy. And what is that? Okay, so we need to answer in terms of x and y. What is that? So you have that equal to y to the fifth. Okay, so this guy is the set that you have here. So set will be at the end changing to y to the fifth. Okay, so this will be your final term or final answer in terms of x and y. Okay, so that is going to be how we solve the Bernoulli equation. Okay, so that is going to be Bernoulli equation here. For the last one, we like to find the particular solution for this guy. So you have xy prime plus y equal to xy square e to the x, and you have y1 equal to e. Okay, so for this one, you're gonna have, okay, so for this one, you're gonna have to put this one in terms of the thing that you're familiar with. So you're gonna get rid of the coefficient of y prime here. So it's gonna be y prime plus 1 over xy equal to xy square. So this guy can be expand into x square y square. So we can expand it. We can expand this guy into x square y square, and you're gonna divide by x, and you have e to the x. So this one will give you x e to the x times y square. So this guy will be n. Okay, so this guy will be n equal to 2. Okay, so you have n equal to 2, and you have 1 minus n equal to 1 minus 2 equal to -1. Okay, and you have qx. Okay, so you have your qx. This one will be your qx and this one will be your px. Okay, so you're gonna convert this guy by letting z to be y to the 1 minus n equal to y to the negative 1. Okay, and you would have dz dx plus 1 minus n px z equal to 1 minus n qx. Okay, so you're gonna have dz dx plus negative 1. Okay, and you have 1 minus n, 1 over x z equal to negative 1. Okay, and you're gonna have e to the x, x e to the x for your qx. Okay, so that you would put down here. So let me just have px qx in the red color so you see pretty clear what you are doing. Okay, so you're gonna basically just plug this guy down, plug this guy down. Okay, so you see that this guy turned out to be linear. Okay, so this guy is linear equation. And so you're gonna have new px. Okay, so that I use the square angle here equal to negative 1 over x. And you have qx equal to negative x e to dx. Okay, so you have mu equal to e to the integral of px dx equal to e to the integral of negative 1 over x dx. Okay, so this guy will be e to the negative log x. That allows you to move this guy up. So this would be this term. Okay, and you have e to the log x to the negative 1. So you have x to the negative 1, or basically 1 over x. Okay, so you have 1 over x for mu. And you're gonna get that equal to 1 over mu integral of mu qx dx. So this guy will be 1 over x, okay? And you have integral of mu, which is 1 over x, x e to the x dx. And this guy will be just x to cancel each other. So basically, okay, let me move this one down. And you see that we can flip this one to be x outside and you get rid of, so it's gonna turn out to be very simple, okay? And this guy will be the orange one that you have the parentheses, so it's gonna be x and you integrate e to the x, it's gonna be e to the x plus z. Okay, so this will be your final answer. Okay, so it's going to be x e to the x plus z for final answer. So what is that? What is that? Z equal to y to the minus 1. Okay, so you have z equal to y to the minus 1. Okay, so z here. Okay, and you have z here. So final answer will be y to the minus 1. Okay, and that gonna be your y, okay, and x for final answer. Okay, we also have y1 equal to e. Okay, since y1 equal to e, we can find c. Okay, so you're gonna just have e, okay, to the negative 1 equal to 1, and you have e to the first plus c, okay, and this c will be just 1 over e minus e, okay, so you have c equal to 1 over e minus e. So for particular solution, you just have 1 over y equal to x e to the x plus 1 over e minus e for final answer. Okay, and I think that's all for this one. You see that this kind of longer solution, however, is gonna consist of 2 steps. Okay, so it's gonna consist of 2 steps. So the first step is around here until you have linear equation. Okay, so this one is your first step, and the second guy will be your second step here. Okay, and that's all. Okay, so that should be all of the things that you need.